Hey YouTube. Alright, so the number one thing I keep seeing going around right now is the ThreadRipper 9000 series, and it seems like every single influencer is reading from the same book. What do you do with a ThreadRipper and 32 cores or 64 cores? Who needs this? What do you do with it? I don't know what to do with it. And they all try to play a game on all the cores. Like, honestly, it's ridiculous. So I'm going to show you what to do today with, if you had a ThreadRipper, what to do with it. This, however, is not a ThreadRipper. This is an EPYC Genoa 9654. This is the closest thing I have to a ThreadRipper. This is 96 cores. This is basically like 96 7900X cores that are clocked down to 3.3 gigahertz. So it's basically just like a lower clocked 7000 series core. So we will see how this works today. Alright, so first things first, I'm going to tear this thing down. It currently has a 4090 in it and a 2 terabyte SSD. I was using this to do test runs just in case I wanted to make this video. Now this is something that I do with a lot of computers. As you guys can see right here, this is one. This is basically the idea of what we're going to do today. If you had a ThreadRipper, what you're going to do is you're going to split it into multiple parts so you could have multiple computers from it. So this computer right here, for instance, I'm going to be able to split it into 4 parts today because I'm only going to hook up 4 GPUs, and we're going to make 4 gaming computers out of this. Now, this would represent what you could do with like a 909970X ThreadRipper, because there's only 32 cores, so 4 would be the max you would want to put on that. Now with this Genoa, this is so more densely packed, I could do 10 VMs on here very easily, but I'll show you 4 today. Okay, so let's go a little overview of what we have here. We have our AMD EPYC Genoa 9654 96 core. This motherboard is a Taiwan. I think it's like an 8060 or something like that. Regardless, it's an SP5 motherboard from Taiwan. It only has 8 memory slots instead of 12, because the CPU can handle 12. But I have all 8 populated with DDR5 ECC 4800 RAM for a total of 256 gigs, because this stuff is very expensive. It's got a 1000 watt power supply, and it has 5 PCIe slots. It's got a couple MICO slots over here, MICO slots. But today we are just going to be using your standard PCIe slots to connect all of our GPUs. And that's where these things come in. This is called a Slim SAS connector. Now they have been updated with MICO connectors, but these Slim SASs can do up to PCIe 4.0, X8 or X16, and this is where all the magic is, because unless you got single slot cards, so unless you really put like the A4000 in here, there's no way to use these slots for GPUs, at least, unless you have somewhere else to put them. So that's where Slim SAS comes in. And they do this on servers. They'll run Slim SAS, like they'll put a motherboard here, and then they'll have a case that extends out where you can put a bunch of cards in, and then they'll have Slim SAS connectors running to all those cards. You're starting to see that like in the Octo servers, that Octominer's just copying Supermicro and all the other big players like Dell and HP. They've been doing these big GPU servers like that for years. Now they're doing those socketed CPUs that have different sort of interconnects. But anyways, that's what we're going to be using today. Another really cool thing about these Slim SAS adapters is, in order to get, let's say, 8 GPUs on here with these 4 slots left, I would take this and run 2 GPUs, one in each of these slots, and each of them would run at 8x by 4.0. This little cable right here plugs into that little PCIe card and then goes into this PCIe card. As you can see, it can do X16. I think I have the X4 covered up. So yeah, that's how it's all possible. So right now this one's set up in 8x mode, but I'm going to run all these in 16 mode since I have 4 slots. So I'll add another cable in here and put them all in. Okay, so I'm going to be using 3 1TB SSDs today for storage, and then we will be putting them in a ZFS configuration. Alright, now that those are all very professionally installed, we can tilt this baby up and push it all the way back to make room for where the GPUs are going to sit. So now we will take a GPU here, run Slim SAS to there, GPU here, run Slim SAS to there, and then put power supplies down here. Can't forget about 10 gig network. That is going to go right here on the bottom. Pow! It's in. Okay, and bam, there's the first GPU. So as you can see, you have the Slim SAS in there, runs out by 8x on each cable into this PCIe riser, and now I have a 3060 Ti as the first GPU. Here's what I got so far. I have a 3060, a 4070, and a 3090 Ti that all the fans died, so this is what I did. I should have just turned it into warranty. Anyways, it's a whole different issue. They're all connected with Slim SAS in there, and I'm going to end up putting a 4090 right here. I am just going to bring some power supplies in and start bringing some power supplies underneath here before I put that last GPU on. The kids are having a great time though. And voila! All of them are in, hooked up with power. So 4090, 3090 Ti, 4070, 3060 Ti. And this will just kind of go and show what we're going to do here is we're going to start here and work our way up to see when 8 cores of this 96 core beast will start to bottleneck. And the whole point of this experiment is this works great. Okay, this is a normal desktop 13700K. I have 2 VMs running on just P cores, and this works fantastic. But this is about as much as you can scale it. You might, if you were able to plug in a third card, and give it E cores, or all E cores, and it would probably do okay. To be honest, it'd probably do just fine. But that is that rig. While this can do the same thing. Like, just because you have 96 cores though and a bunch of RAM doesn't mean you're going to be able to give a VM 30 cores and it's going to be super fast. It doesn't work that way. But the sweet spot I'm finding is 8 to 12 cores. Okay, so if you give every VM 12 cores, then it would be just like a clock down 7900X. But today we're going to do 8 cores, so this will show how it'll scale. Ooh, it'll scale if you were using a ThreadRipper. So as you can see, I'm using these 1200 watt power supplies from HP servers into these breakout boards and then into this spaghetti mess, and that's what's powering all this. I have this cable that splits one cable into 2. And that's how I'm going to do this. I'm going to plug it into 240 volt I have routed over from my dryer to here, because you're going to need a lot of power to power this. One 110 breaker probably won't power this thing. So that's something else to keep in mind. But the whole point of this experiment today is to see what GPU this CPU starts bottlenecking at with 8 cores, because that would be what a 32 core ThreadRipper would scale at, right? And the ThreadRipper should do whatever this can do and better because the clocks are higher. So this would be a fun experiment. and I'm excited to see how well it or doesn't, how good or bad it does at this whole experiment today. Next step is to make sure you turn on all the GPUs before you turn on your computer. And now if you're dealing with like this server class hardware like the EPYCs are, you always want to make sure you have a VGA monitor and hook it up to the VGA port in the back, because a lot of times these server class motherboards will only output video to the VGA. As you can see, boom, instantly output video to the VGA, while these will stay blank. But if you have like UFI and CMS in the BIOS turned off, these will eventually get signal at the very last second. So you may miss a bunch of important things, or may miss an early warning and then be stuck rebooting it because you missed the BIOS button or whatever. And that kind of sucks, because these take a few minutes to get through their post or their pre-boot to get it into the BIOS. So just something to keep in mind. I'm going to be booting into Proxmox and installing that. I won't really be going through a detailed step-by-step on how to do Proxmox. There's plenty of tutorials out there, but pretty much you want to get a USB key, set it to UFI. I think that's the only way Proxmox works on a USB key anyways. Make sure this is set to UFI in your boot settings, and then you want to point it to boot to the USB key. So for me, I'm just going to tab all the way over here. I am going to go down to this and just have it force boot into it, and that should bring me up the Proxmox boot screen. And it is. Welcome to Grub. So I'm going to get this installed. This is something I did want to show you guys, was on the installer, you have all of your hard drives right here, or SSDs, or whatever you're using. This is where you need to set up your RAID, essentially. And what I am going to do is I am going to do ZFS RAID 1. And as you can see, there's all different kinds of options: ext4, XFS, ZFS, and BTRFS. I like ZFS if you have the resources. So it is done and booted. So I am going to go to this IP address up here, and I will log in. So I went to this IP address with the port right here, and I logged in with the username and password. And now we're sitting here, and you can see Genoa, my data center with Genoa, which is the server we just made. So the first thing you're going to want to do is you're going to want to come in here, and you're going to want to put ISOs in here. So you're going to want to upload, select a file here. So I'm going to do Windows 11. That will upload. Now I got both of those uploaded. I'm going to come back over here to my server. Now the reason why I am using Proxmox instead of Unraid in this scenario is because of the core count, and that makes a big difference. Now Unraid will work, no problem. But you will lose a little bit of performance due to scheduling issues, even if you pin the cores and do all that. I'm sure there's ways to get really underneath the hood, but just going through this really quickly and firing this up and doing what a normal user is going to do without getting underneath the hood with just the switches you have available, this is unavoidable. Once you get over about 64 cores, Unraid has a real hard time scheduling. Even at 64 cores, it has a hard time scheduling. So that's why I use Proxmox. Now, Proxmox isn't a one-use-all thing. Proxmox, I've seen a lot less performance on chips like the 7900X, 5900X, 13700K versus the performance I'm getting. Now, this is all gaming performance, but versus the gaming performance that I'm getting in Unraid. So I use this as a rule of thumb. If you're using consumer hardware, Unraid is better. If you're using server class hardware, Proxmox is better. That's what I've learned, and to me, that piece of information is very, very valuable. So the next thing we're going to do is we're going to go to our data center tab, we're going to scroll down here to resource mappings. This is very, very important when you're doing PCIe pass-through. We're going to come in here, we're going to look for our graphics cards. Here we go. Here's one. Here's the 4070. So we want to click on that. We want to pass through all functions as one device. We are going to name this RTX 4070. The name does have to start with a letter, not a number. Keep that in mind. And we're going to click create. And now we have a RTX 4070 right here. So let's do this for all of the GPUs. Have all of these GPUs mapped. You can see our resource mappings. They're all mapped and they're all ready to use. So now we're going to go and we're going to go over to back to our local server that we made, and we are going to create a VM. I'm going to name these VMs what the GPU is. We're going to do next. We are going to set this all up. I want to add additional VirtIO drivers. Go next. Just use this pool for everything. This is just my local, those 3 hard drives that we band together. Okay, let's do advanced. Let's do new 16 V cores, because this is about each thread, not CPU. So 16 threads is 8 cores. And we want, this is also very important, you want it to do a host. You want it to use host CPU, not an emulated CPU. Memory, let's crank this up. We'll give each one of ours 32 gigs. Since we're only doing 4, we can afford it. Okay. Network is all good, and we are good. You don't want to assign any GPUs to this yet. You want to get Windows fully installed and set up with all the drivers and Windows updates that you can get done first, and then you want to pass through the hardware. So I'm not going to bore you with that. I will see you guys once I get the VM up and running. We're here in Windows, and one thing I want to show you guys is, not how to install Windows, because you can figure that out on your own, but it's this part right here. When you get to this point and you're on a VM, here's how to get around it. You basically hit Shift F10. It brings up the command prompt. Type in TASKMGR. That brings up your task manager. Okay, we don't need the terminal anymore. You can close that. Now, you want to come over here to this tab and click on Alt, so it holds Alt down for you. And then you want to come in here and click on Network Connection Flow. In the task, as you see, the background changes. Hit retry, and now this is why you have that Alt button held down, because you tap your Tab button now, and you can tab back over to your task manager. And you keep killing this task just over and over. And now, as you'll see, boom, I can log in as a local user. Oh, make sure you come back and undo Alt and then user. Boom. So, just a little trick. I hate that they make that so hard and hidden, but it's something I've used, and I have a bunch of ISOs that I save just so I can make sure I can do this every time and then update them after I install. So I just wanted to show you guys that little quick bit. Now that Windows has finished installing and we are here at the desktop, that is where that VirtIO will come into play that we set up earlier. You go here, you go to your File Explorer, you go to this PC, you go to your CD drive with the VirtWinIO, and then you install Windows Guest Tools, which will give you all of the drivers that you need to run your Windows VM. With all of that done, we now have internet. So now we are going to just update Windows and clean it up. We've finished installing Windows. We've finished updating it, debloating it. Now I've installed Parsec. Just it's something I do in all my VMs so I can log into them that way. and now I'm installing Steam. So, and the reason why I'm doing that is I'm going to go ahead and download all the games I am going to use with this. Still have not passed through anything, so I'm going to hop onto Steam and just do that real quick. Well, that is, Steam is downloading stuff. I'm going to come in here and enable remote control and enable remote so we can get into it that way, and set a basic password as well so we can get in to remote in with desktop on Windows. And then I'm also going to change the name, but I'm not going to do it yet. And the reason why is I'm going to end up within Proxmox right over here. I'm going to end up cloning this VM for all of my other GPUs. So I'm going to clone it 3 times with the games installed, all the drivers done, everything like that. And then I've placed the NVIDIA driver right here. So basically, one thing I love about VMs is it's way faster to set up VMs and a hypervisor than it is to sometimes set up a bare metal machine, if you know all the quirks and know how to get around everything. So this way, once I finish one, I won't have to install Windows 4 times. I'll install it once and then just copy everything. So it's a lot easier. Something also to note here is I'm using the console right now to connect to the virtual machine. Once you pass through a GPU, you will not be able to use the console to do this anymore. It won't work. That's why it's so critical that we make sure we set up a basic password and make sure remote works and Parsec's installed. Parsec's an option if you're going to use this as a headless machine, but that's a very critical step. So when you pass through the GPU, a lot of times you won't get a screen on the monitor you're trying to output if you have a head on this virtual machine until the drivers are installed. So you need a way to get into the computer still and install drivers. And then I make it easier to myself by just putting the drivers here on the desktop so I can come in and install very, very easily. A lot of people just boot it up and wait and roll the dice and see if Windows will catch it, and Windows will install a base driver. Then their screen comes up and then they go and install their drivers. I don't like doing it that way. I just rather remote in, use remote desktop and do that. So that is what I usually do. I get everything prepped, and then after I'm done copying all the virtual machines, I'll go into each virtual machine. All I have to do at this point is boot each one up, rename it, reboot it, then shut it down, and then I can start adding hardware. The VM's all done, it's shut down, and it's ready to be cloned. So we have all the Windows updates done, everything we want installed, all debloating done that we want done. So now it's time to clone these things. So I'm going to come in here and click clone, give one. And we're just going to click clone, and it's going to come up and it's going to clone. And you get a little status bar down here. So I'm going to do that and make all the VMs that we need, and then we will start passing through some hardware. All VMs are copied, as you can see, 3060 Ti, 4070, 3090 Ti, and 4090. They're all here. So now I need to boot them all up. I need to rename them, all these names, so it's easy for me to remember. All the computer names, that is. So I need to go into the console and start renaming them. And then once I get that done, we will pass through the GPUs, each appropriate GPU to each VM. Back up after renaming. This is a critical step. You come up here into your remote desktop and you verify that you can get in before passing through the VM. So yes, I can get in. That is a good sign. Now you are ready to pass through the VM. Shut it down. And you come over to hardware. Once this is fully shut down, this green arrow will go away. So we will just wait for that to fully shut down. There it goes. Now you come up to hardware. You're going to go to add. You're going to go to PCIe device. You are going to go to mapped device. You're going to click on which one you want. Make it your primary GPU, and you're going to want to make it PCIe Express and take off the ROM bar. Go ahead and click add. And we will fire it up again. With it booted, we need to go back into it through this now and install the GPU drivers. This is a critical step. Sometimes Windows will take over and try to install it beforehand. While those drivers are finishing up, we can pass through our mouse and keyboard. So you go back to hardware, to add, USB. You go to pass through full, and I need this. These are now done, and we have a video on the screen. This is kind of what it looks like with all the screens on to all those GPUs. So we got the 4070 up there, 3060 Ti right here, 3090 Ti, and 4090. So we will be starting benchmarks. Alright, so they're all running a benchmark all at the same time. The reason why I'm doing this benchmark right now, the New Haven benchmark, is because it is something that I can have all four run at the same time. All the other tests I'm going to do are on Steam, so I'm going to have to do them independently. So, but I wanted to show everybody that you can run them all at the same time. The 4090 is doing over 100 FPS, but it's doing everything maxed out in 4K on an LG CTV. This is the 3060 Ti, maxed out in 1080p, 137 FPS. 4070, 157 FPS. Look how smooth, just buttery smooth, no stutters, no nothing. And 3090 in the 200 and something FPS range. So that means the CPU is doing 200 and something FPS right now. Let's see CPU usage. Okay, so CPU usage on the 3060 is only around 10%. Same thing. So it should be right around the same for all of them. This one's at 15 for the 3090 because it's going, oh yeah, look at the 3090 because it's pushing so many more FPS. It's pushing it way harder. So the 4090, yeah, in the 5s, 3070s, and the 8s, the high 7s, 4070s, and the 10s to 12s. 3090 Ti was hitting 15.5% there for a second. Oh yeah, there it goes, up in the 14s again. So not bad at all. Not bad for CPU usage at all. There is something just super cool about having this set up all coming from one rig. Just crazy. Crazy. Technology is so crazy. The heat from over here is also crazy. The power it's pulling is crazy. You gotta take about 160 watts off that or so. So it's pulling like a little over 1400 watts right now. Because the 160 is for the other computer that's plugged in, but that's nuts. Okay, so everything finished. Let's go over it. The 3060 Ti did 142 FPS. The 4070 did 169 FPS. Nice. The 3090 Ti did 243 FPS. So that's fantastic. So we know, based off of that, that none of the previous GPUs were bottlenecked at 1080p by the CPU in this workload. And the 4090 did 106 FPS in 4K. And the reason why I'm doing this one in 4K is because I don't care if the CPU is bottlenecked in 1080p or not. I don't really care if it's bottlenecked in 4K or not, because no one's buying a 4090 for 1080p. So this one's going to do all this tests in 4K. Let's go over the results of the Tomb Raider benchmarks. So as you guys can see here, the 3060 Ti got 136 frames, and the CPU render got a minimum of 85 FPS with it only being 36% GPU bound. This, honestly, this result, not this, but this result right here to me was surprising. I thought this was going to be at 100%, but for some reason, and this honestly for some reason was a little stuttery. I don't know why. None of the other, every other one was buttery smooth, but this one was like stuttering for some reason. So it wasn't super bad. It was just every once in a while there was a little hitch. So that was a surprising result there. If we jump down to the 4070, you see the frame rate jumps up to 157, and so does the minimum CPU frame rate. It jumps up by like 20%, actually a little over 20%, by 1 FPS. So that's really weird. While the max frame rate basically stayed the same, this went up a lot, and that is kind of consistent throughout the rest of the GPUs, as you'll see. Now this isn't surprising. This is 0% GPU bound. This is also at 1080p, as you can see. So basically, if you were running these cards in 1080p and had a 144 hertz monitor or 120 hertz monitor, even a 96 core EPYC, 8 cores of this 96 core can push most of your games to your refresh rate with the right GPU, even with the 3060 Ti. Even though, I mean, maybe the CPU has to do more work with these drivers than the 4000 drivers. I'm not really sure what happened here, but I am impressed with the 3060 Ti GPU. Anyways, the 3090 did 164 FPS, so just a little bit better than the 4070. But you can see the CPU render down here. Ooh, that's kind of a blurry picture, but you guys can see that it's pretty consistent. The CPU even did better here. I don't, maybe this is a driver thing, I don't know. That's a little surprising that we have, I mean, the minimum frame stayed the same, but the maximum changed. It's even higher than both previous cards. So I think that's a little interesting. And then you got the 4090 down here, did 156 frames in 4K. And all of this is no DLSS. All my tests will have no DLSS on. So, and that's 27% bound. So even like how I used my 4090, right? If I was playing Tomb Raider, right, I only have 120 hertz 4K TV, right? So this is way above 120 FPS. I could, you know, V-sync this and lock this to 120 FPS, and I'm gonna have a perfect gaming experience. And the CPU is not even gonna be stressed, because you're gonna be, you know, below what it's doing. So I think those are great results. I thought this was very interesting. I thought, why not try the 3090 Ti in 4K and see where that lands, right? And this is very, very interesting. This was 100% GPU bound. So if you were going to run a 3090 Ti or anything below that, so anything, the only things above a 3090 Ti are 4080, 4090, and the 50 counterparts of that, 5080 and 5090, right? So if you don't have one of those cards and you have a 3090 Ti and below, so I mean all 3000 series, all 4070s and below, right, and you didn't want to use DLSS, you're talking you're already GPU bound 100%, and this will stay consistent. So, you know, if you were going to use this for a 4K setup and you didn't have a 4080 or better, then you'd be just wasting your CPU anyway, which I think is gnarly. So anyways, I thought that was very interesting that, this CPU is able to keep up, and it's probably better than a lot of the lower end, desktop CPUs out there. And the final results of the EPYC is going to be Monster Hunters Wilds. Now, this is a good benchmark because it really stretches the machine, CPU and GPU side. 3060 Ti. Now, all of these were stutter-free and buttery smooth, so I don't really know what was going on for the 3060 Ti on the last one, but this one did 52 FPS in 1080p, fully maxed out. So that, that's impressive. So you 3060 Ti owners, man, good job. Here's the 4070. The 4070 did excellent, as it says right here. I mean, 68 FPS, 1080p, maxed out, and all of this is no frame gen, no DLSS, no trickery, just real frames. So then you got the 3090 Ti that actually did worse than the 4070, which I find very interesting. And then you got the 4090 in 4K that did 64.5 frames. Now this is also very good. I just did a bunch of testing in this game for a desktop, and a non-pinned 13700K only gets about 84 frames, about 20 frames better. That's a lot better, but you're not really going to be frame chasing when you're splitting an EPYC. You're going to be looking for steady frame rates, trying to be above a certain amount, and you're looking for smoothness. Now, I guess you could just, you're not going to frame chase splitting a computer like this at all. But as you guys can see, this is a very, very viable gaming option, even if it's not. This is a server class CPU. It's not a gaming CPU by any means, but you could divide it up into 10 different computers, and technically it gets more FPS in games than any CPU on the market. If you were to add up all of these, right, and you were to put this on 10 different machines. So technically, if you were to put 10 4070s on this machine, every machine should perform the same as this one did. And it would get, that CPU, if you ran them all at the same time, at 10 machines would only be 80 cores out of the 96, right? So you're talking a little over like maybe 85% usage, and that CPU is putting out 680 FPS on Monster Hunters Wilds. See, computers don't work like most people think. You can't just throw more at one problem. It doesn't scale like that, but it scales like in parallel, right? You can do parallel workloads where I'm doing a bunch of the same thing at the same time on different cores, but I can't have all the cores doing the same thing. It's kind of like when you work on a big project. Everybody can work on their own part of the project, but if not everybody can work on the same part of the project, right? So you bottleneck yourself that way. Anyways, I thought this was very interesting. 96 core EPYC, technically, if you want to get all technical, could be one of the best gaming CPUs out there if you add up all the VMs, FPS, and all the work the CPU is doing in parallel, right? Because even though single core performance on, let's say, that 13700K rig is a lot better, and it does do 2 VMs a lot better than this one can do 10, not really, like, only if you're frame chasing. Like, in actual playable experience, you're not really going to be able to tell between one of these, if you did 10 of these versus playing on the 13700K split into 2, right, or a 7900X split into 2. You're not going to really tell a difference. That's the craziest part, I think, about this experiment. And then you can get these EPYC CPUs for right around the same price on eBay and stuff, for right around the same price as you can get one of those ThreadRippers. Now, I'd be interested if someone, wants to send me one or whatever. I'd be super interested to see what a new ThreadRipper does compared to this. Just split it up into four computers, because you're not going to be able to do. I guess if the ThreadRipper is a lot more powerful per core, you wouldn't have to do 8 cores per game of VM. You could drop it to 6 or even 5, and I guess you could pack more than 4 in there. But you're going to be limited by PCIe lanes on the ThreadRipper. Like this one has 128 lanes, so I could do all 10 virtual machines. So in conclusion, I think that this did very, very good today. So I'm very impressed. If you're going to use this for 4K or 1080p gaming for 120 FPS or below, this works great. So yeah, that works. So if I had a ThreadRipper, what I would do is I would split it up. If I had a 32 core ThreadRipper, I would split it up into four computers. That's what to do with a ThreadRipper, because there's not very many workloads. Just like everybody's saying, there's not many workloads that are going to take advantage of all those CPU cores, right? This is the workload that takes advantage of all those CPU cores that I can think of, other than running like a LLM or something. So